I think we have good people on the call. Let's start off, Vinay. I think you can
Okay,
start with something about yourself. Then I think people will know, and then we can start off with this thing.
okay, sure. All right. Yeah. So, thank you all. First of all, thank you for joining the session today and taking some time out of your busy schedule. So, my name is Vinay Agarwal, and I'm working with VMware as a senior consultant on the VCN portfolio. That's basically the NSX portfolio. So, my core expertise is around NSX, container networking, and NSX ALB. So today's topic is about how we can secure our containers, uh, how we can basically provide microsegmentation like our virtual machines to the container applications, right? And how we can manage that microsegmentation right from NSX. So that's the today's topic. So we will be covering NSX and Antrea in our today's session. So I will be walking through the journey about all this microservices security. Please feel free to ask any questions. You can post them in Q&A. I would prefer if you can post the questions in Q&A instead of the webinar chat, so that it will be easier to track. I will take a look at the questions at separate intervals and try to answer those questions then and there. I will also share my personal contact information. So if you are interested in learning more about the container security, or if you want a deep dive, maybe we can connect later on. So with that, I will start the session. Thank you again for joining and hope you will find this informational. So first of all, this is a disclaimer. This is a standard VMware disclaimer. Even though I have taken care to not include any feature information that is under development, or any feature that is not currently GA, but still, if I speak about anything, or if I speak about any forward-looking statements, please take them with a pinch of salt, because they might get changed, or any feature that is currently in the tech preview that is bound to change. It may or may not be GA. Okay. Okay, so talking about today's agenda, so we have an action-packed agenda for today. So before I start talking about all the mumbo jumbo about microservices, containers, networking, security, let's do a quick crash course on the microservices. Let's see what microservices is, and what is container, what is Kubernetes, what is their different architecture, before we deep dive into our Antrea and NSX integration with Antrea, so that everybody have a same baseline of understanding. I will try to keep it as simple as possible to avoid any technical jargons. But if you have any questions, or if you have any doubts, please feel free to pop those in the Q&A. And last but not least, we will have a use case demo. So I have prepared a live lab today to walk you through. So I would like to keep the theory as limited as possible, and provide more of the time on the lab aspect, so that you can see the things running in the action. With that, I have tend to be a bit brave today. Usually I do a recorded demo, but for the first time, I'm going with a live demo. So sometimes live demo do not work as expected, and they bound to get failed. So if such situation arises, I apologize in advance for same. Okay, so let's start with the first topic, that is our crash course on the microservices. Let's see what is microservice, and why should we care about it. So before we start with the microservice, first we need to understand what is an application. If you ask anybody in the IT or non-IT person, everybody have their own definition about application. One can say it's an interface, one can say it's a front end, one can say it's software that can process certain business logic, one can say it's a database that stores all of your data, right? So whoever is looking, so it's like a elephant in the room, everybody blinded and blinded by a blind scope, and they are just trying to touch and feel the elephant and see if they can make out what they are touching and feeling. So same cases with the application. The definition of application is very vast, but the key element, if you ask anybody, for an application is, number one is the interface. So there should be some kind of interfaces so that we can connect to the application, or different components of application can connect to each other. Then there is the user experience. So it needs some kind of a front end input mechanism. So where as a end user, I can go and I can interact with the application, right? Then there will be business logic. Basically, it will be a function or functionality according to which my data or my inputs are processed. And last but not least, the most important bit, that is the data. So this data is basically how my application is processing the inputs and saving it accordingly. So it could be a persistent data, means we are saving it somewhere in a database, or it could be a non-persistent data, like we are just processing it and discarding it later on. Okay. So why I'm talking about application? Because the thing is, the application architecture has basically changed over its period of time. We started with the monolithic architecture, and today we are talking about microservices. So before I directly jump onto the microservices and talk about what is a microservice, let's see what is a monolith. So in the old days, what used to have, not all days, still when we call it as a traditional application, is basically I have a single box, right? And in that single box, I have all the 4 aspects of my applications running. So if I talk about user experience, if I talk about database, if I talk about my interfaces, or if I talk about my business logic, all these different components are hosted inside a single box. That's like a monolith. So it's a single box. Now, the problem with the monolith is scalability. Like if you want to scale it, it's not really easy to do so. If you want to upgrade it, you have to upgrade all the different components of the application. And if I talk about a client server, so basically what we have done here in the client server, we have taken our user experience out of the monolith and basically make it as a client. So now the front end of the application is running on the client system, and there is another piece sitting in the environment, which we call it as server, where all my rest of the interface, business logic, and my database is running. So it's like a client server communication. So both of these are connected over the network. So now I can independently upgrade my client uh, irrespective of the server. So the one thing I can think of in respect to the VMware world is if you think about your vCenter in the older days, so my vCenter server, there used to be a thick client, right, which I used to install on my desktop VM or my machine where from where I need to take control of my vCenter environment. Now, this thick client was completely independent of my vCenter server. I could have upgraded it as per my requirement. Okay. Now, moving on, after we move from client server, there is something called N-tier architecture. Now, in the N-tier, what we have done is now instead of combining all these application components in a single one, we have divided them out. So basically now there is one server which is running UX, one server which is running business logic, one server which is running database, and another machine, which is another box, which is running my basically what did I forget? Interfaces. Okay. So there could be multiple tier. It could be a single tier, 2-tier, 3-tier, 4-tier, depending on the number of application components that we have, right? But all these components are connected to each other via the network. Now, the flexibility here is, let's say if I need to increase the capacity of my database, I can basically increase the capacity of database irrespective of my input, the interface mechanism or business logic mechanism, right? But what if we can go one step further and divide our application into multiple business logic? What do we mean by that? What I mean by that is, now it's like I have my, so in a single application, I could have a database for multiple functions. Let's say I could have a user database, right? I could have a order database. So if I take a shopping application, an example, I could have users database, I could have a orders database, I could have a inventory database, right? So all these different form of databases, now in the end tier, they will all be combined into a single database box. But in the microservices, what I can do is I can divide all these databases into different functions or different like different boxes. So now I have another box which is running user database, another box running order database, another box running inventory database. Similarly, I have another box running my front end, another box running my order page, another box running my inventory page, right? And there could be another box which are running like my RabbitMQ interfaces, which are basically taking the inputs from all these different uh, components and transmitting it to each other, right? So as you can see in microservices, what we have done is we have divided our application components by their function. So instead of running multiple functions on a single box, now I'm running each function on a separate box. So I have an example application, a demo application that I have prepared in Kubernetes, which I will show you. So that will give you a little bit more clarity in the demo. But basically, this is what microservices is. Now, let's say in the Black Friday or in the Deepavali sale, we have a burst of users coming in, right? And they want to all access the shopping function of my application. So instead of scaling my application instead of scaling like multiple boxes, what I can do is I can simply and easily scale my shopping function of the application as the load increases, and as my load decreases, it will basically scale those out. So that's the benefit of microservice. Instead of, it gives me the flexibility and scalability to run as I need. Now, as we understand microservice, and we saw those different components, right? So each function is running in its own box, and we call that box as a container. So basically, the smallest unit in a microservice is a container. Okay. So I was talking about that user database. I was talking about that inventory database, or I was talking about my front end function. So where all these different components are running, all these different components are running in the containers. Okay. So let's take an example how the containers differentiate if I speak in if I compare it to the traditional one. So let's say I have two bare metal server. One is running in a non-container environment. Another one is running in a container environment. So usually what we do is we install our hypervisor layer on top of it, so we can virtualize the resources, right? And on top of our hypervisor layer, what we do is we create virtual machine. And inside my virtual machine, I have operating system and application. So basically, each application needs some kind of a runtime environment. It could be a Linux environment. It could be Windows environment, which is basically provided by my operating system. So that's a non-container environment. So even if I need to scale my application, I need to spin up these multiple VMs, which can take some amount of time. Even though we are using automation, it can take some minutes to spin up these virtual machines and make them ready. Okay. Now, what will happen in a container environment Yes, I am running a virtual machine. Okay, now this could be run directly on a bare metal server as well. And I am running a operating system. But after operating system, I install another layer, which we call it as container runtime engine. Okay, CRE. Basically, this container runtime engine do the same function which is done by hypervisor. So in hypervisor, we are virtualizing our server. Container, we are virtualizing our operating system. So on top of container runtime engine, now I can run my application, okay, which are independent of my OS. So these applications are in the form of images, which I can pull them from the internet or from my private repository and run them on my container engine. So all these shared binaries and everything, they are provided by these container runtime engine in order to for that application to work properly. Okay, so in containers, we have additional layer, which basically enables the operating system virtualization. Okay, so that's container, well and good. Now compare this container to our ESXi host. So in our ESXi host, what happened? I have my virtual machines running. What will happen if your ESXi host goes down? Downtime. How will you fail over all of your virtual machines from that ESXi host to another ESXi host? So the same problem I have with my containers. I have a container runtime engine running and containers running on a single operating system, and that operating system goes down. What will happen to my containers? They will all be down. So how can I provide the high availability services to my containers? Okay, and this is where the Kubernetes comes in. So Kubernetes is basically a orchestrator platform which provides the resources or platform to basically manage the containers. So Kubernetes is one of the platform. There is another platform like Docker Swarm. Okay, but Kubernetes is open source and it is widely used. So that's why by default it has become the default orchestrator for the containers. Okay, so let's compare this Kubernetes with our VMware analogy. Okay, so I talk about my ESXi host. Okay, so this is my ESXi host. Okay, on my ESXi host, I have my VMs running, VM1, VM2. What if I want to provide the high availability services in my ESXi, in my vSphere environment? What I need to do is I need to create some kind of cluster. Okay, I need to create a vSphere cluster. So what will happen? So even if my one ESXi host is down, it can automatically fail over the virtual machine on the second host in the same cluster. Okay. And what do I need to create this cluster? This is where the vCenter comes in, right? So vCenter provides us that management functionality to create a cluster, to configure and manage our vSphere environment. So let's take a similar example with the container. So now I have my OS, okay, or my basically nodes. Let's call them nodes. So nodes are like my operating system installed virtual machines. Machines. These could be virtual machines or these could be bare metal servers as well. Doesn't matter. Okay. But most of the time you will see 90% of the time these will be bare metal. These will be virtual machines. Now, if I'm running my containers on top of these nodes, I need to form some kind of cluster so that if my one node is down, my container can basically move or fail over to the other node. Okay. So I need to create a cluster. because we are talking about Kubernetes, we call it as K8s cluster, Kubernetes cluster. The short form is K8s, right? And in order to manage this whole environment, we need Kubernetes. So Kubernetes is like technology. It's not it's like a product. Okay, within Kubernetes we have multiple you can say components or uh, multiple utilities. So one of that utility is kubectl. Okay, so kubectl is basically a CLI utility through which I can manage my entire Kubernetes cluster. Okay, now this once I have this Kubernetes cluster, now I can provide the high availability, automated orchestration, the placement for my uh, containers. Right, that's great. Now let's take it one step further. So what if, let's say, all these ESXi host within vCenter server, what I can do is I can create something called as resource pool. Okay, so resource pool, what it provides, it provides that compute resources for my virtual machines. So basically, let's say if I want to limit my compute resources for a certain set of virtual machines, I can create multiple resource pools, right? So let's say I can create two resource pool, one for production and one for non-prod, and I can basically assign certain limits or reservations or shares so that resources are not competing with each other. Okay. Similarly, in Kubernetes, we have something called as namespace. So namespace basically provides the compute resources to run your containers. Now, inside vSphere environment, we can create something called as VApp. Okay, virtual application. So this VApp, it could consist of one VM, two VM, three VM, or multiple VMs. Okay. Similarly, in Kubernetes, we have something called as pod. So pod is the smallest unit in Kubernetes. Remember, in microservices, the smallest unit in container, but in Kubernetes, the smallest unit is pod. Now, pod basically consists of containers. So you can run one container, two container in a pod. It can be a single container pod or it could be a multi-container pod. So that's how we can map it. Now, also, vCenter Server provide us something called as VDS or vSphere distributed switch to manage the networking, okay, in the vSphere environment. And similarly, in Kubernetes, we have something called as CNI, Container Network Interface, to manage the networking within the environment, okay, within the Kubernetes environment. Now, we will take a look at why we need this CNI, okay. So what is this Kubernetes CNI is responsible for? What is its use? Okay. So basically, the Kubernetes CNI is responsible for the main function of this is providing the connectivity between the pods and assigning the IP addresses. Now we discussed that we have multiple nodes in a Kubernetes cluster. So let's say I have node here, node 1, node 2. And also one important concept, in a Kubernetes environment, we have two type of nodes. One is called as controller node, okay, and the another is called as worker nodes. So worker node are basically where my actual application is running, and controller node is basically provides the entry point to your Kubernetes cluster. So it basically it is responsible for scheduling the pods. It is responsible for if any pod got failed or any pod got deleted or any pod got stopped, then controller node basically monitors these desired state of my pods and make sure they are up and running as per their configuration. Okay. And worker nodes are where my actual pods are running, my application pods are running. Okay. Now, so I have pod running here, I have pod running here, I have pods running here. Okay. How do they communicate with each other? They need IP address. Now I have my DNS services in it. How they connect to each other, how they resolve the name for each other. So all these network connectivity between these pod is provided by CNI. Okay, so that's the first bit. Now the second bit, all of these ports, because they need to connect to each other over the network. So what do they need? They need IP address. So who provide that IP address? It's the CNI or the container network interface who provides that IP address with the help of IPAM or IP address management. Okay, so each pod will have its own IP address assigned to it. Now, another thing, it is optional network policy. So what if I want to restrict the communication between these pods? So I say that, hey, I have a dev pod running here, I have a prod pod running here. I need to make sure the communication between these two is not allowed. Okay. So who control that policy? So this is where the CNI comes in. So all these network policy management, connectivity, IPAM, all these three critical functions are provided by CNI. Okay. So that's how the networking looks like in the container world or in microservices. So this is just the VMware product placement, like how the VMware products provide container networking. So at the very bottom layer, the operating system or infrastructure as a service layer, we have NSX providing connectivity and network policy enforcement between my virtual machines. Then load balancing can be provided by NSX ALB. Then my network policy in the container as a service layer provided by Antrea, NCP, or ALB. And if I go one step further, like if I need to provide my the protection, endpoint protection services on my containers, on my microservices applications, then this is where the Carbon Black container services comes in. So today's topic is focused around this layer, which is providing the policy control between all these different pods. Okay. Right. Before I move on to Project Antrea, let me see if there are any open questions. So there is one question: nodes provide redundancy to the pod which host container. What benefit it provides when it runs on hypervisor? Do hypervisor provides failover HA as difference, as we already have replica set for pod across the nodes? Yeah, you are right. So basically, vSphere HA provides the high availability services for my VMs or my nodes, right? So if my one of the ESXi host is down, so my node will be failed over to the another ESXi host, and it will come online over there. And you are right. Basically, the redundancy in the microservices or in the Kubernetes is provided with the help of replica set. So I could run like multiple replicas of my single pod. So they work in tandem with each other. They are not conflicting with each other. So let's suppose I have my ESXi host 1, 2, 3 here, right? And let's say I have my node 1 running here, and this ESXi host goes down. So what will happen? This node can fail over here, node 1. Okay. Now, imagine you were running this node on a physical server. Okay. Now your physical server is down. So you have effectively lost the capacity of your node 1. You have lost your node 1. Until unless that physical server is online, you have lost that capacity. Okay. So that's the difference between the physical world and the virtual world. Okay, talking about Project Antrea. So what is Antrea? So previously we discussed about the CNI, right? So there are different types of CNI. There is like Kubernetes CNI, which is native Kubernetes CNI, which we can use. Then there is Calico, you might have heard about, or Flannel. Okay. Similarly, there is Antrea as well. There is also another NCP. So the key thing about Antrea is it's an open source project, and it's a CNCF project, right? So it combines the Open vSwitch. It is built on top of Open vSwitch and built into Kubernetes natively. And because it's open source, so it's available to everybody. The main benefit of this is Antrea can run anywhere. It is primarily being developed by VMware, NVIDIA, Intel, right? And then AWS and Microsoft, IBM are also contributing to this project. The key thing here is Antrea can run everywhere. So whether I have vanilla Kubernetes, whether I have managed Kubernetes like Tanzu, Rancher, OpenShift, EKS or AKS, or GKE. So I can run my Antrea on all these different platforms. Okay. And the another thing is Antrea can be integrated with your existing technologies, like we have vRealize Network Insight, or now ARIA operations for networks, Wavefront, NSX, Tanzu. So if you are already using these NSX or Verni, you can integrate your Antrea with these components and manage your Kubernetes policies from a single console. So instead of managing your Kubernetes policies separately using YAML files or any other platform, you can use NSX to provide those policies. You can manage those policies from the NSX itself. So that's the benefit of Antrea. Another features which are provided by Antrea, so it supports Antrea network policies, cluster network policies, multi-cluster network policies, layer 7, IDS. Currently, IDS is in tech preview for now. So VMware do not provide supports for IDS, but yes, IDS is available in tech preview. It provides egress, SNATing, then multi-NIC support. Also, it provides the traceflow and network visibility inside the Kubernetes environment or inside the Kubernetes application. So some of these security policies and the visibility aspect or the traceflow aspect we will cover in the demo. Unfortunately, for IDS, I was not able to set it up. So the IDS demo could not be there. But if you want to learn more about the Antrea IDS, we can connect later on separately. So if I talk about the Antrea architecture, it's very similar to the Kubernetes architecture. There is one controller and one agent. Okay, so my Antrea controller is running on my Kubernetes controller node, which is receiving all these user inputs related to your network policies, related to egress configuration, etc. Right? And then it pushes that configuration to the agent, which runs on my worker nodes, and it enables those policies with the help of Antrea proxy. Okay, so as simple as that. There is one controller running on the Kubernetes controller node. With the help of API, we basically connect to the controller using Kube API, and that controller pushes those policies to agent, and it implements those policies in the data plane with the help of Antrea proxy. Okay, so that's Antrea. So let's focus on the main topic, which is NSX integration with Antrea. So with the help of NSX and Antrea, the key benefit is managing those security policies from the same interface. So you can manage your VM policies and Kubernetes policies right from a single window. And if you want to use the trace flow mechanism in NSX, you can use that. If you want to collect the support bundle, that is also supported. So some of the things, like if you want to implement network policy, port-to-port security, namespace level isolation, or cluster level security, you can manage all these things from NSX. So you will be able to provide these policies within the NSX GUI. But if you need to configure any FQDN filtering or layer 7 API rules, then you need to directly use the Antrea Antrea interface with the help of YAML files to implement those policies. So what difference does it make by integrating NSX? Nothing. Your data plane, control plane, and agents remain same. Only thing is we have one more pod, which we call it as interworking pod, that gets introduced in the picture. Now, this interworking pod basically have two functions. One is MP and then there is CP. Okay, so MP management plane, basically it connects to the NSX manager. So any policy that we configure on NSX manager uses the MP to basically send those policies to the Antrea, and then Antrea MP send those policy to CP or my control plane adapter, and that control plane adapter connects to my Antrea controller to basically push those policy to the pods. So only one pod that got introduced between the NSX and the Antrea controller to facilitate that communication. Now, the key thing here is even though the policies are being realized on the on the Kubernetes environment, right? You can make the changes directly in the Kubernetes environment, but the single source of truth will always be NSX manager. So whatever policy you have configured in NSX manager, that will be treated as the absolute truth. Okay, so even if you make any changes on the Kubernetes side, basically NSX manager will see that as a configuration drift, and it will basically again push those policies back to management plane and control plane to basically reconfigure those policies. Port IPs are internally by default, and it would be managed by either with NSX or Antrea, right? Do we have any situation where we need routable IP for port? Yes. With the help of Antrea and NSX, you can create those routable ports if there is a requirement that is possible. Okay, so basically your ports will be directly routable to the outside world, like VM sitting in the environment. I cannot use traditional VDS. You can use traditional VDS. So again, inside the Kubernetes environment, it's Antrea that is working, but your Kubernetes environment is running on some kind of operating system. Now, where are you running that operating system? Are you running that operating system in a virtual machine? If yes, if you are running that operating system in a virtual machine, at the end, it will get connected to VDS. Okay, I hope this resolves your question. Right. So I will post the slides here. So I will directly take you to the demo and show you these use cases. And then I might come back to the slide just to show that IDS. So let me stop sharing my screen and let me share my lab environment quickly. Okay, so this is my lab environment, right? So let me show you what. Let me walk you through the lab environment first, like what is what, and then I will show you all those different use cases, security policies, trace flow, etc., live in action. Okay. Oops, what happened? Yeah. Let me increase the size a little bit. Yeah. All right. So this is my vSphere environment. Okay. So there was a question, can I not use traditional VDS? So if you see here, I have my Kubernetes cluster. So because this is a lab environment, I'm only running two nodes in my Kubernetes environment. One is running as a controller node and the another is running as worker node. Now, if you look closely, my controller node and worker node, they are connected to my traditional vSphere distributed switch pod group. Okay. Um, right. So that's how it is. And then I have my ALB, NSX ALB, providing the ingress to my Kubernetes application. Then I have a couple of test VMs, uh, which I will use for the testing purpose. And then I have my Verni environment or ARIA operations for network to basically collect the flows from the Kubernetes pods and view them in the uh, environment. Okay. What else? Yeah, NSX. So my Kubernetes environment is already integrated. So let me walk you through my Kubernetes environment first. So like I said, in order to work with the Kubernetes environment, I need some kind of utility, which is kubectl in this case. So let's do get nodes. Okay, so like I said, in my Kubernetes environment, I'm running with the two node cluster. One is working as a controller node, one is working as worker node. They are running Ubuntu 22.04 operating system, right? So again, I'm using virtual machine, and on top of virtual machine, I have installed my Ubuntu. And on top of Ubuntu, I have installed my certain engines. So in this case, I have installed Containerd as my container runtime engine. And on top of that, I used certain um, uh, Kubernetes Kubernetes pods. So let's view those pods. So kubectl get pods -a. So -a is basically for the entire namespace. Oops. Let me run that again. Yeah. So if you see here, so in this Kubernetes environment, I have multiple pods running. Okay. So anything you see as kube system, so these are my Kubernetes system namespace. So like I said, the first thing we have is the namespace. So it provides isolation, uh, the compute isolation for your pods running in the environment. Okay. So cube system is basically, this is where I have all my different uh, essential pods running for the Kubernetes environment. Like I have kube scheduler, which basically schedules the pods on the worker node. Then I have my controller manager. I have my kube API server. So kubectl is connecting to the kube API server to get entry into the environment. Then I have my etcd, basically it's a database, key value database. Then I have my core DNS, which is basically my DNS services running in the environment. Then because I'm using Antrea as my container network interface, so I have my Antrea agents. So like I said, you will have Antrea controller running on the running on the controller. I think there was some issue with this, so that's why it's running on the worker. But yeah, so you have one controller running, and then you have two agents. Agent is running on each and every uh, Kubernetes node. Okay. And then I have some of my applications. So I have a demo application which is running in its own namespace. It's basically a shopping website that I'm running. And then I'm running AKO for my L7 ingress service. And then I'm running my two kind of testing pods to basically test the policies, right? And as you can see, these different IPs. So these pod IPs, as you see here, these pod IPs are assigned by the CNI automatically. So while initiating the Kubernetes, I need to provide a subnet, like which subnet will be used by the pods, and it will use those. Uh, be mindful, these IPs are internal to Kubernetes environment. These are by default, these are not routable to the outside world. So I cannot reach them directly. Okay. If I want to connect to my application, what I need to do, I need to create something called as service. Okay, so as you can see, I have multiple services running here. So you can see one front end service, which is exposed on port 30,001. Similarly, I have flow aggregator, some Antrea, some RabbitMQ, some cards, etc. And if I show now that ingress, so as you can see, I'm running ingress service shop.ako.corp.local on port 80. Okay, this is being facilitated by NSX Advanced Load Balancer. So if I go to NSX ALB, so you see this uh, the virtual service running in the ALB, which is pointing to these two pods running. Sorry, these are the node IP exposed via the node port. Okay. Now, because I have already integrated that, you might have seen that interworking pod running on my controller node. If you see here, this VMware system Antrea, so you see this interworking pod, which is running. And inside this, you can see there are 4 different containers to it. Okay. So basically, this is the pod, which is facilitating the communication between the Kubernetes cluster and my NSX. So if I go to my NSX, what I have done here is under user management, you see this Antrea admin. So I have created a principal identity user using the certificate. So I have provided that value, this user information in my interworking pod. And using this principal identity user, my interworking pod and NSX are communicating with each other. Now, if I go to inventory, you will see the containers and you see all the different clusters. So as you can see, my cluster namespace, the container cluster name is Vanilla Kubernetes 8 cluster. CNI type is Antrea. Kubernetes type, there are 2 nodes. There are how many pods are running. So all the information that you need will be visible right there, all the services inside your NSX environment. And if I go to namespace, you see all these different namespace. And if I expose this namespace, you see this ingress rule. If I click on that ingress rule, you will see that, hey, I have a ingress shop-ingress running. And if I click on view detail, it will show me all the specification of my ingress service. Okay, so what's the benefit? So the benefit is comes number 1 in the group. So now I can create different groups. So as you can see, I have created a group called Antrea Ingress. And if I look at the logic, So this is a generic group. So starting with NSX 4.1, now I can combine my virtual machines and my Kubernetes services together. Okay. Otherwise, it would have been Antrea. So as you can see, I am using my Kubernetes ingress to basically create a membership criteria for my group. Similarly, if you can see, there is a Antrea pod front end. So these are type Antrea group. So if I go to criteria, if I see the membership, now this is a Antrea type group. So we create Antrea type group. If I need to facilitate pod to pod network policies, I create a generic group. If I need to facilitate VM and Kubernetes policies. Okay. So this is where you can see I have created a criteria based on my namespace. All right. Now let's go to security. So if I go to security and go to distributed firewall, you can see I have created two different type of policies. The number one policy is a pod to pod policy. So as you can see, I have created Antrea pod default. And if I click on this view member, you will see BusyBox and web server type of pods, which are running in my Kubernetes environment. Right now they have allowed. So I have allowed the communication from my web server pod to my demo application. So let's see if that is working or not. So my service, front-end service is exposed here. Okay, so right now I am inside the pod web server. And if I run curl, oops. Let's do it again, front end. Okay, so right now you can see I can get the response. So let's change this policy to a drop policy, okay? Meanwhile, we are here, I will change, I have two VMs, one is a web VM, one is an app VM. I will change for one of them to drop, and only HTTP is allowed. I will change the rest of the policy to the drop policy. Okay, let's give it a time, success, close, dismiss. So if I go back here to my this, let's do a curl again. Now you can see it's not working. Reason, we have changed our policy right there from the NSX. And how can I verify that? If I do a kubectl get ACNP, that's my Antrea container policy. And if I do a -o JSON, it will show me that the action is drop. So that's how I can manage my container policies right from my NSX. So that's one thing. But what about my VMs and my containers? Can I manage that? Yes. So let's see that example. So I have two VMs. So if you see this application has stopped working because I changed this rule to drop, right? And if I try to do a ping, you will see the ping is also not working. But if I do this from my web VM, the application is working fine. But the ping will not be working. Okay. The reason being, I have set this policy as drop here. If I change it to allow, you see, after changing our policy, the ping starts working. And if I see here, my website is also working. So that's the benefit. I can manage all these security policy right from my NSX, whether it's VM, whether it's containers. Now, another cool thing, if I go to my traffic analysis, traceflow, let's say I want to do a pod to pod communication, so I can do it. Let's say I want to do a TCP, and the destination port is 80. The pod is my worker one, and if I select the default namespace and web server, and my destination is my sock-shop, which is my application, and I want to do it on the front end. Remember, I have blocked this, and you can see it will show you whether the communication is allowed or not, or whether it is being dropped by some of the application. Right. Another thing, if I go to this. So I have integrated my Kubernetes cluster with the help of Antrea to my Verni. So what I can do is I can gather all the different flows right into my Verni. So I can do that IP analysis, flow analysis right in the vRealize network inside. And if you have integrated it with NSX, the additive benefit is you can manage your application. So right now I have created one application, Weave Socks, and it will show me all those different tiers that I have. Because this is being running for like very recently, I do not have sufficient flows to show like the traffic flow between them, and neither I have created any segmented policy. That's why you do not see any arrows like from where to where the communication is going. But yeah, if you configure all that, let it run in for a while, you will see like the VMs, you will see all that flows being captured here in the ARIA operations for network as well. So this is my SOX application. Then there is, if you are using Antrea, and if you have heard about Octant, you can use that to basically visualize all of your application. Okay, so if I go to front end, it will show me all those application details, like my front end pod. It's being exposed through front end service, which is being exposed through shop-ingress. Okay, and if I go to Antrea, I can basically view the details about my agent controller, and the same trace flow functionality you will see in here as well. So if you want to do a trace, you do not have NSX, you can utilize the Antrea traceflow plugin to basically get the same functionality right from the here. Okay. Yeah, so this was it from the demo perspective. I hope you find this useful.
I think it's very interesting things. Vinay, how the things are moving in the NSX and Andrea, how it is coming up as a CNI and CRI tightly integrated all together. It's pretty
Yeah.
decent.
Yeah, and unfortunately, I was not able to show ideas because that is not ready. But yeah, means if you have NSX ATP or TP license, you can integrate Antrea with NSX and utilize those NSX signatures, IDS signatures, to basically get the IDS functionality for your pod services. That's another cool demo, maybe for another day.
Yeah, so they'll also feature like whenever you're downloading the images from unknown source. So that'll also
Yes.
help.
Yeah,
That's pretty
exactly.
interesting. All right, guys. So any questions you have for Vinay, please pop them out now.
So I have pasted my LinkedIn profile and my email ID in the chat. So if you guys would like to connect or do a deep dive and connect separately with me over Antrea or container networking in general, or just to say hi, please feel free to reach out.
Vinay, this just one question is there which I think we can take up.
Yeah.
So one of the attendees asking that with use of Antrea, can we reduce the installation of firewalls?
Okay, so see, there are two things. When you say firewalls, number one, the firewalls they cannot like I'm speaking purely in terms of traditional firewall or the physical firewalls, right? Like Palo Alto or Checkpoint. Um, we do not have that, at least I'm not aware of any direct integration, like they can provide that network policy in the Kubernetes environment. Okay. So for that, you need a CNI, like Calico, another very popular interface, or Antrea or NCP. The key benefit here is the management aspect. So now you, instead of managing all these network policies separately for your VMs and separately for your containers or Kubernetes pods, you can manage them from a single interface. That's the main key point here.
So answer is it'll definitely reduce the load of on your firewalls with
Yes.
in your east-west, but for the
Yes, east-west.
north-south,
For the north-south,
definitely.
yeah, perimeter firewall is again, yeah, that will always be there.
So guys, I hope everyone liked the session and the content. It was pretty interesting. So we're coming to close off on another VMUG session. I hope everyone liked it and enjoyed. So very soon we'll have a session in person. So we're planning to have that session pretty soon in person. So thank you, everyone. Thanks for your time. Thanks a lot, Vinay, for giving us a valuable insight onto the technology. Thank you, everyone. We are just closing this session now. Thank you. Thanks for your support.
Okay. Thank you, everyone. Thank you for your
Thank
time.
you.
And
Thanks.
thank you for
Bye.
the opportunity. Thanks. Bye-bye.